when the mind learns to stop trying. Imagine an animal placed in a difficult situation. At first, it struggles, searches for solutions, and experiments with different responses. Then, after repeated failure, something changes. The animal stops trying, not because escape is impossible, but because it has learned that effort no longer matters. This quiet psychological surrender is known as learned helplessness, one of the most influential concepts in modern psychology and behavioral neuroscience. Learned helplessness describes a condition in which individuals, after repeated exposure to uncontrollable negative events, come to believe that they have no control over outcomes, even when control is later restored. This belief affects motivation, emotion, cognition, and even brain function. The theory has helped explain depression, anxiety, trauma responses, academic failure, workplace burnout, and even political apathy. It also carries a sobering message. Sometimes the most damaging prisons are the ones we build in our own minds. The psychological foundations of learned helplessness. The concept of learned helplessness was first formally introduced in the late 1960s by psychologist Martin Seligman. At the time, psychology was heavily focused on behaviorism, the idea that behavior is shaped by rewards and punishments. Seligman's work challenged this view by suggesting that what truly matters is not just what happens to us, but what we learn about our ability to influence what happens. At its core, learned helplessness involves three key psychological deficits. 1. Motivational deficit, reduced willingness to act or try. 2. Cognitive deficit, impaired ability to learn that control is possible. 3. Emotional deficit, increased anxiety, stress, or depressive symptoms. When individuals repeatedly experience negative events they cannot control, such as unavoidable punishment, chronic failure, or unpredictable trauma, they may generalize this lack of control to new situations. Eventually, they stop attempting solutions altogether, even when escape or success is clearly available. Importantly, learned helplessness is learned, not innate. It is not laziness, weakness, or lack of intelligence. It is a rational adaptation to past experience that becomes maladaptive when circumstances change. Attribution theory and individual differences. Not everyone exposed to uncontrollable events develops learned helplessness. This observation led to refinements of the original theory, particularly through attribution theory. Seligman and colleagues proposed that helplessness depends on how individuals explain failure. Explanations vary along three dimensions: internal versus external, it's my fault versus the situation caused this; stable versus unstable, this will never change versus this is temporary; global versus specific, I fail at everything versus I failed at this task. People who attribute failure to internal, stable, and global causes are more likely to develop chronic helplessness and depression. In contrast, those who view failure as external, temporary, or specific are more resilient. This insight helped bridge learned helplessness with clinical depression, shifting psychology toward a more cognitive understanding of emotional disorders. Depression, in this view, is not merely sadness, it is the belief that action is futile. Behavioral neuroscience. What happens in the brain? Behavioral neuroscience adds a crucial layer to the story. Learned helplessness is not just a mindset, it has measurable neural correlates. The role of the stress response. Central to learned helplessness is the brain's stress system, particularly the hypothalamic pituitary adrenal (HPA) axis. When an organism encounters uncontrollable stress, the HPA axis becomes hyperactivated, releasing stress hormones such as cortisol. Short-term stress can be adaptive. Chronic, uncontrollable stress is not. Prolonged cortisol exposure can impair memory formation, emotional regulation, decision-making, neuroplasticity. This biological wear and tear is sometimes referred to as allostatic load, the cumulative cost of chronic stress on the body and brain. The dorsal raphe nucleus and serotonin animal studies have identified the dorsal raphe nucleus, DRN, a serotonin-producing region in the brainstem, as a key player in learned helplessness. When an animal experiences uncontrollable stress, DRN neurons become hyperactive. Excess serotonin is released to certain brain regions. This disrupts normal coping behaviors. Ironically, serotonin, often labeled the feel-good neurotransmitter, can contribute to passivity when released in the wrong context and location. It's less happy chemical and more situationally misunderstood chemical. Crucially, when animals are given control over stress, even minimal control, DRN activation is reduced, and helpless behavior does not develop. The brain seems to care less about stress itself and more about whether the organism has agency. The prefrontal cortex, the brain's control center. The medial prefrontal cortex, MPFC, plays a protective role against learned helplessness. This region is involved in executive control, decision-making, regulation of emotional responses, assessing controllability. When the MPFC detects that an organism has control over a stressor, it actively inhibits the stress response system. However, chronic uncontrollable stress can impair prefrontal functioning, reducing this top-down regulation. This creates a vicious cycle. Loss of control weakens the prefrontal cortex. A weaker prefrontal cortex makes it harder to recognize new control. Helplessness becomes self-sustaining. Neuroscience thus confirms what psychology suspected: learned helplessness reshapes the brain. Classic experiments. Where the theory began. Seligman's dog experiments. The most famous experiments on learned helplessness involved dogs, conducted by Seligman and Stephen Mayer. In the initial phase, dogs were placed in harnesses and exposed to electric shocks. One group could stop the shock by pressing a panel. Another group received shocks regardless of their behavior. A third group received no shocks. Later, all dogs were placed in a shuttle box where they could easily escape shocks by jumping over a low barrier. The results were striking. Dogs that previously had control quickly learned to escape. Dogs that had no control did not even try. They lay down and whined, passively enduring the shock. These dogs were not incapable of escape. They had simply learned that escape was useless. This experiment demonstrated that prior experience with uncontrollability can override instinct, learning ability, and physical capability. Rodent studies and neurobiological precision. Subsequent experiments with rats refined the findings. Researchers showed that rats exposed to uncontrollable stress failed to escape later stressors. Rats exposed to controllable stress did not develop helplessness. Artificial activation of the prefrontal cortex prevented helpless behavior. Inactivation of the prefrontal cortex induced helplessness even without prior uncontrollable stress. These studies provided causal evidence linking brain circuits to learned helplessness, transforming it from a psychological concept into a neurobiological model. Learned helplessness in humans. Although early experiments focused on animals, learned helplessness applies powerfully to humans. Depression and anxiety. In clinical psychology, learned helplessness is closely associated with major depressive disorder. Depressed individuals often report beliefs such as, "Nothing I do makes a difference," "Trying is pointless," "I have no control over my life." These beliefs are not merely symptoms, they are mechanisms that maintain the disorder. Therapy approaches such as cognitive behavioral therapy, CBT, aim to reverse helplessness by restoring a sense of agency and control. Education and academic failure. Learned helplessness has been observed in educational settings, particularly among students who experience repeated failure or harsh evaluation. Such students may stop attempting challenging problems, avoid participation, underestimate their abilities. Importantly, intelligence is not the issue. Perceived lack of control is. Teachers who emphasize effort, strategy, and improvement rather than fixed ability can help prevent the development of helplessness. In other words, grades teach lessons beyond math. Workplaces and social systems. In organizational psychology, learned helplessness explains burnout, disengagement, and apathy in environments where employees feel powerless. Constant micromanagement, unpredictable rules, and ignored feedback can teach workers that initiative is useless. At a societal level, learned helplessness has been used to understand how populations exposed to chronic poverty, discrimination, or political instability may disengage from civic action, not due to indifference, but due to learned futility. Recovery and prevention. Unlearning helplessness. The encouraging news is that learned helplessness can be unlearned. Restoring control. Research shows that even small experiences of control can reverse helplessness. Allowing individuals to make meaningful choices, however limited, can re-engage motivation and learning. Cognitive reframing. Changing explanatory styles from global and stable to specific and temporary helps weaken helpless beliefs. This is a core strategy in psychotherapy. Behavioral activation. Action often precedes motivation, not the other way around. Gradual engagement in achievable tasks can rebuild confidence and agency. Neuroplasticity. The brain remains plastic throughout life. With consistent experience of control, prefrontal regulation improves, stress responses normalize, and adaptive behavior returns. The brain, it turns out, is remarkably forgiving, once it's shown evidence that trying matters again. Conclusion. Learned helplessness is a powerful demonstration of how experience shapes expectation, and how expectation shapes behavior, emotion, and brain function. From classic dog experiments to modern neuroscience, the evidence converges on a central truth. Perceived control is fundamental to psychological health. When organisms, human or otherwise, learn that their actions have no effect, they may stop acting altogether. This response is not irrational. It is a learned adaptation to an uncontrollable world. The tragedy occurs when the world changes, but the belief does not. Understanding learned helplessness does more than explain depression or passivity. It reminds us that agency is not just a philosophical idea, it is a biological need. And when that need is met, effort returns, curiosity reawakens, and even the most discouraged mind may try once more. Sometimes hope is not about optimism. Sometimes it's just about learning again, that the door was never locked.